Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on angle between the direction, where they have given a single surface, that is xy equal to z square, with respect to two set of points, 4, 1, 2 and 3, 3, minus 3. Considering this, we are going to find the angle. How? Now let us see. First, represent the angle between the surface or the direction. The angle between the surface is given by cos theta, which is equal to n1 cap dot n2 cap. What does n1 cap and n2 cap represent? The unit normal vector. With respect to this, what does n1 represent? N1 represent gradient phi1 divided by modulus of gradient phi1, and n2 cap represent gradient phi2 divided by modulus of gradient phi2. Done? Now, yes. For this, first we need to represent the scalar function phi. Let us consider the surface or the given equation, that is, consider xy equal to z square, where xy minus z square equal to 0. To represent any scalar function, the equation should be defined with respect to equal to 0. So we have represented xy minus z square equal to 0. Then phi, which is equal to xy minus z square. Now, what I need to find, that is gradient phi1. What does gradient phi defines? Gradient phi represent dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap, where phi is given by dou phi, which is equal to, we are not representing phi1 and phi2. Why? Because considering 1 after differentiation, just we are going to apply the point. When we are going to apply the points, at that time we are going to represent it as gradient phi1 and modulus of gradient phi. That is dou by dou x into, what is phi? We have xy minus z square into I cap plus dou by dou y into xy minus z square j cap plus dou by dou z into xy minus z square k cap. Differentiate this whole scalar function with respect to the given variable x, y, z. That's it. Now let us differentiate the first equation with respect to x. So that let us go differentiate with respect to term by term. That is, let us differentiate first term with respect to x. We have x, y remains constant, differentiation of x is 1, with respect to x is 1, y remains constant, minus differentiation of z square. See, while differentiating z square can be represented as z square into 1, where z square remains constant, differentiation of 1 with respect to any variable is 0. 0 into, with respect to, for example, with respect to x corresponding opposite variable, then you get 0. X square into 0, you get 0. So we always define it is equal to 0. Now into I cap plus, now differentiate with respect to y. So x remains constant, differentiation of y is 1, minus the differentiation of z square with respect to y is 0 into j cap plus differentiation of this whole term with respect to z. So what we are going to do, differentiation of xy with respect to z is 0, minus differentiation of z square with respect to z is 2z into k cap. What we are going to get, gradient phi, which is equal to y I cap plus x j cap minus 2z k cap. This is our standard gradient phi. Now, considering this standard gradient phi, we are going to represent the 2 points. One is 4, 1, 2 and 3, 3, minus 1. For that, consider at the point, first point we have 4, 1, 2, where x equal to 4, y equal to 1, z equal to 2. Now, gradient phi1 is defined as y I cap plus x j cap minus 2z k cap, where gradient phi1, which is equal to what is y? 1 I cap plus what is x? 4 j cap minus 2 into what is z? 2 k cap. Gradient phi1, which is equal to I cap plus 4 j cap minus 4 k cap. This is our gradient phi1. Now let us find modulus of gradient phi1. Modulus of gradient phi1 represent square root of 1 square plus 4 square plus of minus the 4 square. Use the calculator so that you will get the solution in the single line. That is square root of 1 square plus 4 square plus minus 4 square. You get root 33. Root 33. This is our gradient phi1, where we represent the unit normal vector n1 cap, that is gradient phi1 divided by modulus of gradient phi1, that is n1 cap, which is equal to what is gradient phi1? We have 1 I cap, let us represent 1 itself, plus 4 j cap minus 4 k cap whole divided by root 33. This is our first unit normal vector. Okay. Similarly, let us repeat it for the second unit normal vector with respect to n2. Consider n2 cap, which is equal to gradient phi2 divided by modulus of gradient phi2, where we don't have this what two scalar function. I am going to consider this. I am going to represent a deep point. Consider gradient phi2, which is equal to y I cap plus x j cap plus minus 2z k cap, where at the point 3 comma 3 comma minus 3, where x equal to 3, y equal to 3, z equal to minus 3. Now gradient phi2, which is equal to what is y? We have 3 I cap plus x 3 j cap minus 2 into minus 3 k cap. Gradient phi2, which is equal to 3 I cap plus 3 j cap minus into minus plus 3 2s are 6 k cap. This is our gradient phi2. Now let us find modulus of gradient phi2. That is square root of 3 square plus 3 square plus 6 square. That is gradient phi2, which is equal to root 9 plus 9 plus 6 square is 36. That is square root of 3 square plus 3 square plus 6 square. You get 3 root 6. This is our gradient phi2, where second unit normal vector n2 cap defines gradient phi2 divided by modulus of gradient phi2, where gradient phi2 represent 3 I cap plus 3 j cap plus 6 k cap whole divided by 3 root 6. So that I can take the common, it is 3 I 3 into 1 I cap plus 1 j cap plus 3 2s are 6 k cap divided by 3 root 6. 3 3 get cancelled, n2 cap, which is equal to 1 I cap plus 1 j cap plus 2 k cap divided by root 6. This is our n2 cap. Now, to find the angle between the surface, all before itself we have represented. So, I am going to continue here itself. The conclusion. Now, just multiply. That is cos theta, which is equal to, what is n1 cap? We have 1 I cap plus 4 j cap minus 4 k cap whole divided by root 33 into 1 I cap plus 1 j cap plus 2 k cap whole divided by root 6 cos theta, which is equal to 1 into 1 1 I into I 1 plus into plus plus 4 into 1 4 j into j 1 plus into minus minus 4 2s are 8 k into k 1 whole divided by root 33 into root 6 cos theta, which is equal to 1 plus 4 minus 8, you get minus 3 divided by square root of 33 into square root of 6. You get 3 root 22, where 3 get cancelled. Cos theta, which is equal to minus 1 by root 22, where theta, which is equal to cos inverse of 1 by minus 1 by root 22. This is our required solution for the given scalar function with respect to two set of points 4, 1, 2 and 3, 3 minus 3. And this is how we are going to represent the angle between the surface with respect to considering two set of unit normal vector and multiplying those two and representing those two and simplifying and multiplying those two to get the angle, that is cos inverse of minus 1 comma 1 minus 1 divided by square root of 22. I hope you have understood this problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.